Hi everyone. In the live lesson today, what we looked at was the tools that we might use to solve triangles in trigonometry. Namely, we have 5 tools at our disposal. We have Pythagoras and SOHCAHTOA for right angle triangles. And in non-right angle triangles, we have the area of the triangle formula, the sine rule and the cosine rule. In this video, we're going to look at those tools, we're going to look at the website, and we're going to do an example at the end. Okay, let's look at solving triangles. The first and most important rule that we can use with right angle triangles and only right angle triangles is Pythagoras' theorem. And what Pythagoras said was the square and the hypotenuse, this is the long side here, the square here would be equal to the sum of the squares. So the area of this square would be the sum of the squares on the other two sides. So if we could imagine that there was a square on this side, these are the smaller sides, and a square on this side. What I mean by the square is the area of a square that will be standing on it, or in other words, if you square whatever that length of that side is. So that's what Pythagoras says. The information that we're interested in Pythagoras is important. So the information for Pythagoras and why we would use it is if we're interested in a side, and another side. So maybe if you had two sides and want to find the third side, that's why you use Pythagoras. Also to do with right angle triangles, we have SOHCAHTOA. SOHCAHTOA are what we call the trigonometric ratios also. So it tells me that the ratio between sine of an angle is opposite over hypotenuse, cos of an angle is adjacent over hypotenuse, and tan of an angle is the ratio between the opposite and the adjacent. And you must be talking about a particular angle to be able to use these. We would use trigonometric ratios when the information we have are two sides and we want to find an angle, or maybe one side in an angle and we want to find another side. So that's why we would use SOHCAHTOA. Then we have non-right angle triangles. And they tend to be labeled like this. We have angle A and side A is opposite it. We have angle B and side B is opposite it. And we have angle C and opposite that is small c. And we have 3 different rules that we can use. Just to say the Pythagoras' theorem and SOHCAHTOA do not work on non-right angle triangles. But the tools that we have for this, the first tool is the area formula. This is the symbol for area of triangle. And the area of the triangle is half AB sine C. What's important to know using this formula, this is where angle C is, and side A is this side here, side B is this side. That the two sides are the arms of the angle, and otherwise this formula won't work. What I'm interested in, or why would I use this formula? Well, the formula uses two sides, A and B, so there's two sides involved in it. There's one angle that's between those two sides, and there's also the area is given. So the reason I would use this formula is because I'm told something about the area. That's the reason to use this formula. So if the information I'm interested in and have includes the area, well, I'd use the area of the triangle formula. In a right angle triangle, there's no need to use this formula. In a right angle triangle, you could call one of the sides that is not the hypotenuse, you could imagine that to be your base, and the other side, imagine that to be your height. And because these are perpendicular, I have the perpendicular height. So what I would use instead of that in a right angle triangle is just kind of the primary school version of this formula, that the area of a triangle is a half the base by the height. And the reason that's actually the same as this one is because if base by height, they're the two sides involved here, but the sine of the angle between them is 90 degrees and sine of 90 degrees is 1. So it's actually the same as the area formula, but I wouldn't bother use the half AB sine C for right angle triangles. Okay, so we have another tool that we can use is called the sine rule. And the sine rule says that either A over sine A Notice here what I'm dealing with here are, these are opposite to each other, a over sine a, and that's really important that we have this relationship of sides that are across from each other, that a over sine a is equal to side b over sine b. Again, what I'm dealing with here are, these are sides that are across from each other, b and side b are across from each other, opposite each other. There's no need to say it with side c as well. And if this is true, it sometimes suits us to write this the other way if we want to find an angle. It's also true then that sine a over a would be equal to sine b over b. And we could use this formula. Why would we use it? I suppose the sine rule, the reason that we would use the sine rule would be that the information we're interested in are these angle sides across from each other, where we know one complete pair and have half the other pair and want to find one of them. So if what we have is a side and an angle and a side and an angle, and they're the things that we're interested in, well then I would use the sine rule in a non-right angle triangle. The last thing we have is the cosine rule. The cosine rule says a squared is equal to b squared plus c squared minus 2 times bc cosine a. Of course, it's given in the tables and formulas, but you do have to prove this at Leaving Cert higher level as well. So this is my cosine rule. In the cosine rule, just to note again, what we have is we have a side A and an angle A. It's important that whichever side is on this side, it corresponds to the angle here. That's how we place them. The other two sides, it doesn't matter which we call B and C. Why would we use this rule? Well, what we're interested here in this, we have A, B, and C in small letters. In other words, we have 3 sides that we either have and are interested in. Maybe we want to find an angle, or maybe we have 2 sides and an angle and want to find the other side. So this is why we would use the cosine rule. To help you solve triangles, we have a suite of videos available here on the website if you go to the Trigonometry 1 page. So you'll need to practice some of the questions here. So in the book, if you go to sections 2, trigonometric ratios, there's videos there how to use SOHCAHTOA and Pythagoras. In section 3, there's more on SOHCAHTOA and third form. Section 4 is about solving non-right angle triangles using the sine rule, and section 5 is using the cosine rule. And it's a mixture of these sections, in particular sections, maybe 2, 4, and 5 that are important here. Now this is the example from today's class. The lengths of a side of a triangle are 4, 5, and 6. Let's sketch what a triangle might look like. So 4, 5, 6. It doesn't have to be perfect. If you had a ruler, maybe make it a bit neater. It's not a right angle triangle. A comment on this. The largest angle, that would be the one across from 6, is theta, it says. Find the value of cosine theta as a fraction. Okay, in a non-right angle triangle, where we have 3 sides and we're interested in an angle, we'd use the cosine rule. So the cosine rule says that a squared is equal to b squared plus c squared minus 2bc cosine of the angle A. The important thing here, I suppose, is theta and 6 are across from each other. So that's what's happening here as well. I'd like to rewrite this formula before I sub things in. I could sub the numbers in straight away in for A, B, and C. I suppose the important one is that 6 is going to be our A in this formula. I'm going to rewrite the formula though first to imagine what cos A would look like. So if I'm looking at where cos A is here at the moment, I'm imagining if I subtract b squared, subtract c squared from both sides, the left hand side would look like this. On this side we have the cosine A, and if I divide both sides by the negative 2bc, that's the formula, if you wish, for cosine A. And now I'm going to sub the numbers that we have into this. So cos A is equal to 6 squared minus 4 squared minus 5 squared all over negative 2 times 4 times 5. And I take out the calculator and put that into it, and if I do, I see I get 1 over 8 as the answer. And the second question is to show what sine theta is. Now, in these ratios in SOHCAHTOA, if you know what cosine A is, you should be able to work out what sine A is. I'm going to imagine a different triangle. I'm going to imagine a right angle triangle with an angle A. I suppose I should change this. Actually, A in this question was theta, actually, wasn't it? I said what theta is. So I'm going to call one of the angles in this theta. And if this is theta, now this is not drawn to scale, but if that's theta, cos, which is adjacent, over hypotenuse is 1 over 8. And we're asked to find what the sine ratio is. So we could use Pythagoras' theorem to work out the other side. So 8 squared, the square on this side is 64. The square on this side, 1 squared is 1. The square on this side would be 64 minus 1, which would be 63. So this side here, the missing side, would be the square root of 63 using Pythagoras' theorem. The square root of 63 is 9 sevens. The square root of 9 is 3. So I could write this as 3 times the square root of 7. So if I put the square root of 63 into the calculator, that's what it would tell me. Sine is opposite over hypotenuse. So sine of the angle theta, the ratio for this question is 3 root 7 over the hypotenuse, which is over 8. So I've worked out the sine ratio.